Hello students, in earlier sessions I discussed the reduction indeterminate form of indeterminate form 0 by 0. Okay, so similarly one more indeterminate form is infinity by infinity. You consider infinity by infinity is the another indeterminate form. So when we are finding the limits, it assumes indeterminate form infinity by infinity. So then how can we, what methods we can apply to solve that type of problems? Let us see. So that indeterminate form infinity by infinity, indeterminate form infinity by infinity is when you are applying the limit. So if it takes infinity by infinity, so in that time, suppose when we are applying f of x by in f of x by g of x, if you are applying limit of f of x is or f of a is equal to infinity and f of g of a is equal to infinity. Okay, so in that time you can write this same form as, so 1 by g of x by 1 by f of x. Now what, in what form it is? So 1 by g of x means 1 by, so g of a is infinity. 1 by infinity means it takes 0. Again it takes 0 by, that means we can express this infinity by infinity form to 0 by 0 form. For this reason, to the indeterminate form infinity by infinity also, we can apply the L'Hospital rule. But remember, so at one stage we should reduce that one to 0 by 0 form at after first or second step. Okay, first or second or third step, at one proper stage you change that one to 0 by 0 form. So after reducing that one to 0 by 0 form, so then we can easily find its solution. ಬೇಗ ಎಂಡ್ ಆಗುತ್ತೆ 0 by 0 ಫಾರ್ಮಿಗೆ ಬಂದರೆ, ಸೊ ಎಂಡ್ ಆಗುತ್ತೆ ಅಂತ. Okay, so we can apply the L'Hospital rule. Let us see one such example here. So evaluate limit of log of sin x by cot x when x tends to 0. As you take, let k is equal to, so let k is equal to limit x tends to 0, it is log of sin x by cot x, log of sin x by cot x when x tends to 0. Apply the limit, which is equal to log of sin 0 by cot 0. So all of you know that tan 0 is 0, cot 0 is 1 by tan 0, 1 by 0 is infinity. So and also this is sin 0 is 0, log 0 is infinity, so it is infinity by infinity is indeterminate form. Is indeterminate form. When it takes indeterminate form, so now you take so as usually you apply the L'Hospital rule. Apply L'Hospital rule to this one. Apply L'Hospital's rule. So then k can be written as k is equal to limit x tends to 0. So log of sin x differentiation is, it is 1 by sin x, again differentiation of sin x is cos x. This divided by, in denominator cot x is there, so differentiation of cot x is minus cosecant square x. So now simplifying this, k is equal to, so limit x tends to 0. So when you bring this cosecant square x to numerator, it becomes sin x. So it is minus sin square x, and in numerator cos x is there, so it is cos x. This divided by sin x. One of the sin x cancels. So to this sin x, what is remaining? Sin x into cos x is remaining. So k is equal to limit x tends to 0. It is minus sin x into cos x. Apply the limit, which is equal to k is equal to minus sin 0 into cos 0. Cos 0 is 1, but sin 0 is 0. 0 into 1 is equal to 0. So the limit value case is equal to 0. Similarly, you take one more example. So limit of tan x to base x, log of tan x to base x when x tends to 0. So take this is k, let k is equal to limit x tends to 0. That function is log of tan x to base x, log of tan x to base x. I think you know this, log a to base b can be written as log a to base e by log b to base e. So it is a very familiar result. So log a to base e can be written as log a to base e by log b to base e. Similarly, we can write this one is k is equal to limit x tends to 0. We can write this is log of tan x to base e, if you are not necessary to mention e here, and log x to base e. Apply the limit k is equal to log of tan 0 by log 0. As you know that tan 0 is 0, log of 0, log 0 by log 0. Don't say it is 1, okay? So it is infinity by infinity. So infinity by infinity, it takes infinity by infinity form. Once again it takes infinity by infinity form. Yes, k is equal to, so it is indeterminate, so then, so you can apply the L'Hospital rule here. Apply L'Hospital rule. Apply L'Hospital's rule. So then k is equal to limit x tends to 0, differentiate log tan x. It is 1 by tan x into differentiation of tan x is secant square x. This divided by log x differentiation is 1 by x. Differentiation of log x is 1 by x. So now you can write this is k is equal to limit x tends to 0. You see this x comes to numerator because it is in denominator of denominator, so it comes to numerator. So it is x by tan x. And again you take limit x tends to 0 into secant square x. As you know that limit of tan x by x when x tends to 0 is 1, or limit of x by tan x when x tends to 0, that is also 1 into secant square 0. As secant 0 is 1, so it is 1 into 1 is equal to 1. K is equal to 1. Similarly, you see one more example of infinity by infinity form. So limit x tends to 0 sin ax, log of sin ax by log of sin bx. Yeah, take this k is equal to limit x tends to 0 log of sin ax by log of sin bx. See that log 0 is minus infinity or plus infinity. So log 0. If you don't know that, you take like this, log 0. Log 0 is equal to x. Okay. So then what is 0? 0 is equal to e to the power of x. So when that e to the power of this value becomes 0, so e to the power of minus infinity is e to the power of minus infinity is 0, or in other words, okay, you take 0 is e to the power of minus infinity to e to the power of x. E cancels, so x is equal to minus infinity. So you can take it, log 0 means it is minus infinity, so not plus infinity. So k is equal to, so apply the limit log of sine 0 by log of sine 0. So that is minus infinity by minus infinity. So minus minus cancels, so it is infinity by infinity is indeterminate. Is indeterminate. Okay. So it is the indeterminate form. Then apply L'Hospital rule. Apply L'Hospital's rule. So then k can be written as k is equal to limit x tends to 0. Differentiation of log of sin ax is it is 1 by sin ax. Differentiation of sin ax is cos ax. Differentiation of ax is a. This divided by, so it is 1 by sin bx. Differentiation of sin bx is cos bx. Differentiation of bx is b. So like that. Yeah, now it is k is equal to, this is k is equal to, yeah, it is a cot x. You can write it is limit x tends to 0. It is a cot x. Cos ax by sin ax is cot x. A cot ax by, so this is b cot bx. B cot bx. So one thing is you can differentiate this again, or in other words, so if you apply the limit, it is cot 0 and cot 0. It becomes cot 0. Cot 0 is tan 0 is 0. Cot 0 is infinity. Again it takes infinity by infinity. To avoid infinity by infinity form, so you bring this cot to numerator. Cot bx by cot ax. So then it assumes it's 0 by 0 form. 0 by 0 form ಬರ್ಕೊಳ್ಳೋದ್ರಿಂದ ಏನು ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದರೆ, ಸೊ ಪ್ರೋಸೆಸ್ ಬೇಗ ಎಂಡ್ ಆಗುತ್ತೆ. x tends to 0, it is a into this becomes tan bx by b into this cot ax comes to denominator, it is tan ax. So now you apply the limit, or you can solve the problem here itself. So by using tan x by x formula, or otherwise you can apply the L'Hospital rule once again. Okay, when you apply the limit to this, it is like this: a tan 0 by b tan 0. Yes, tan 0 is 0. 0 by 0 is indeterminate. ಇಲ್ಲೇ ಹೇಗೆ ಎಂಡ್ ಮಾಡ್ಬೋದು ಅಂದರೆ, ಇದರಲ್ಲಿ tan ax by ax ಅಂತ ಬರ್ಕೊಂಡ್ರೆ, ಸೊ ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು 0 ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಸೊ ದಟ್ ವ್ಯಾಲ್ಯೂ ಬಿಕಮ್ಸ್ 1. ಕಷ್ಟ ಆಗೋದಾದರೆ ಅಥವಾ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ ಅನ್ನೋ ಕಾರಣಕ್ಕೆ, ಸೊ ನಾನು ಮತ್ತೆ L'Hospital ರೂಲೇ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀನಿ. ಸೊ ಅಪ್ಲೈ L'Hospital ರೂಲ್. Apply L'Hospital rule. So then k is equal to limit x tends to 0, it is a into differentiation of tan bx is secant square bx into b. This divided by b into differentiation of tan ax is secant square ax into a. Here we can cancel this b and b cancel with b and a cancel with a, and to remaining one you apply the limit. ಇನ್ನು ಉಳಿದಿರೋದಕ್ಕೆ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಾವು k is equal to secant square 0 by secant square 0. Secant 0 is 1. 1 by 1 is equal to 1. So the limit value is equal to 1. So limit value k is equal to 1. Similarly, one more example is there here. So limit x tends to pi by 2, tan x by tan 3x. So usually you take this is k is equal to, let k is equal to limit x tends to pi by 2, tan x by tan 3x. Apply the limit, k is equal to tan 90 by tan 3 into 90. As all of you know that tan 90 is infinity. Tan 90 is infinity. Tan 270 degree is also infinity. Or you can write it as tan 180 plus 90. 180 plus is in third quadrant tan is positive, so it is also tan 90. Tan 90 is equal to infinity. Is indeterminate. If it takes indeterminate form, so then apply L'Hospital rule. Apply L'Hospital's rule. If you apply L'Hospital rule to this, then limit extends to pi by 2. Differentiation of tan x is secant square x. Secant square x by differentiation of tan 3x is secant square 3x into 3. Secant square 3x into 3. What is secant 90? Cos 90 is 0. Secant 90 is, so secant 90 is 1 second, it is infinity. Infinity ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂದರೆ ಇದನ್ನು ಡಿನಾಮಿನೇಟರ್ಗೆ ತಗೊಂಡು ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿ, ಇನ್ಫಿನಿಟಿ ಅವಾಯ್ಡ್ ಆಗುತ್ತೆ. ಸೊ ದೆನ್ ಇಟ್ ಈಸ್ ಕೆ ಇಸ್ ಈಕ್ವಲ್ ಟು 1/3 into limit extends to pi by 2. You take this is cos 3x or cos square 3x by cos square x. Now you apply the limit. K is equal to 1/3 into cos square 3 pi by 2 by cos square pi by 2. Cos 90 is 0, cos 270 is also 0. 0 by 0 is indeterminate. ಯಾವಾಗ 0 by 0 ಬರುತ್ತೆ ಅದು ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಲ್ಲೇ ಪ್ರೋಸೆಸ್ ಎಂಡ್ ಆಗುತ್ತೆ, ನಮಗೆ ಬೇಕಾಗಿರೋ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. 0 by 0 ಬರ್ತಾರೆ ಇನ್ಫಿನಿಟಿ ಬೈ ಇನ್ಫಿನಿಟಿನೇ ಇಟ್ಕೊಂಡ್ರೆ ಅದಂಗೆ ಮತ್ತೆ ಮತ್ತೆ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಬೆಟರ್ ಟು ಕನ್ವರ್ಟ್ ಟು 0 by 0 ಫಾರ್ಮ್. 0 by 0 ಫಾರ್ಮ್ ಬಂದ ಮೇಲೆ ನಿಮಗೆ ಬೇಗ ಅದು ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಇಲ್ಲ ಅಂತ ಅಂದರೆ ಮತ್ತೆ ಇನ್ನೂ 2-3 ಸ್ಟೆಪ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ಐ ಆಮ್ ಅವಾಯ್ಡಿಂಗ್ ದಟ್ ಇನ್ಫಿನಿಟಿ ಬೈ ಇನ್ಫಿನಿಟಿ. 0 by 0 ಬರೋ ಥರ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. So to this one you apply the L'Hospital rule. So apply L'Hospital rule. So then K is equal to 1/3 into differentiation of cos square 3x is limit extends to pi by 2. Okay, differentiation of cos square 3x is 3 cos, so sorry, it is 2 cos 3x. 2 cos 3x into differentiation of cos 3x is minus sin 3x. Again differentiation of 3x is 3. This divided by differentiation of cos square x is 2 cos x into differentiation of cos x is minus sin x. That's all. So here you can cancel this 2 and 2. 2 cancels, ಅಥವಾ 2ನ ಹಾಗೆ ಇಟ್ಕೊಂಡ್ರೆ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ದಂಗೆ. If you wanted to keep that 2 here, keep this 2 as it is. Okay, then we have 2ನ ಹಾಗೆ ಇಟ್ಕೊಂಡ್ರೆ ಒಂದು ಬೆನಿಫಿಟ್ ಇದೆ. Okay, keep this 2 as it is, but you can cancel this minus and minus, no problem. So then K is equal to 1/3 into limit extends to pi by 2. 2 sin theta cos theta can be written as 2 sin theta cos theta can be written as 2 sin theta cos theta is equal to sin 2 theta. So you can write this is sin 2 into theta. Theta means that is 3x. This divided by 2 sin theta cos theta is sin 2 theta. That is sin 2x into 3. This 3 I am writing here. This 3 and 3 cancels. 3 cancels. Again you apply the limit. ಮತ್ತೆ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡೋಣ. K is equal to, this is limit extends to pi by 2. This is sine 6x by sine 2x. So if you apply the limit to this, limit x, so it is it is sine 6x wait. So if you apply the limit, it is sine 6 into pi by 2, sine 6 into pi by 2 by sine 2 into pi by 2. 2 to cancel, 2 ones are 2 threes are sine 3 pi, sine 3 pi is 0, sine pi is 0, is indeterminate. Again apply L'Hospital rule. Apply L'Hospital rule to this. So ಮತ್ತೆ L'Hospital rule apply ಮಾಡಿದ್ರೆ so then we have k is equal to limit extends to pi by 2. Differentiation of sine 6x is cos 6x. Cos 6x into 6. Differentiation of sine 2x is cos 2x. Cos 2x into 2. Okay. So this is 2 ones are 2 threes are. So now k is equal to 3 into, apply the limit, it is cos 6 into pi by 2 by cos 2 into pi by 2. 2 cancels, 2 ones are 2 threes are. It is cos 3 pi by cos pi. T into what is cos 3 pi? Cos 3 pi can be written as cos 2 pi plus pi. Cos 2 pi plus pi. Cos 360 plus theta is in first quadrant. In first quadrant it is cos pi only. So it becomes cos 3 pi is cos pi. So this is cos pi divided by cos pi. Cos pi value is minus 1, minus 1, minus 1 cancels. So remaining is 3. Therefore the limit value k is equal to 3 in this case. The value of k is equal to 3. Okay, like that you take one more example. Limit extends to 0 tan 2x to base tan x. Let k is equal to limit extends to 0. This is log of tan 2x to base tan x. Log of tan 2x to base tan x. So now you can write this is k is equal to limit extends to 0. You can write this is log of tan 2x by log of tan x. This is because log of a to base b can be written as log a to base e by log b to base e, that e is not necessary to write that. So now k is equal to, you apply the limit to this, it is log of tan 0 by log of tan 0. Tan 0 is 0, so minus infinity by minus infinity, so is indeterminate. Okay, now you apply L'Hospital rule to this. Apply L'Hospital rule. If you apply L'Hospital rule, so then k can be written as k is equal to limit extends to 0. Differentiation of log tan 2x is 1 by tan 2x. Differentiation of tan 2x is secant square 2x. Again differentiation of 2x is 2. This divided by Differentiation of log tan x is 1 by tan x. Differentiation of tan x is secant square x. Is secant square x. Now you write this is a is equal to, so you try to stop the problem here itself. That means you try to find the solution in this step itself. How it so this is by the method of simplification. If you arrange the terms properly, so you can end the problems in itself, in this step itself. Otherwise you have to continue again by applying a L'Hospital rule. ಇಲ್ಲ ಅಂದರೆ ಮತ್ತೆ ಮತ್ತೆ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕಾಗುತ್ತೆ. ಇಲ್ಲೇ ಹೇಗೆ ಅವಾಯ್ಡ್ ಮಾಡೋದು, ಯಾವ ಥರ ಇಲ್ಲೇ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸ್ಟಾಪ್ ಮಾಡೋದು, ಇಲ್ಲಿ ಇದೇ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ಸ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಅಂದರೆ, ಸೊ if you are applying x by tan x when x tends to 0 ಫಾರ್ಮುಲಾ, ಸೊ ನೋಡಿ ಏನಾಗುತ್ತೆ ಆ ಥರ ಅರೇಂಜ್ ಮಾಡ್ಬೋದು ಆ ಸ್ಟೆಪ್ಸ್ ಅಂತ. ಸೊ ಈ 2ನ ಇಲ್ಲಿ ತಗೊಳ್ಳಿ, ಇಟ್ ಈಸ್ 2 by tan x tan to x, 2 by tan to x, this divided by 1 by tan x. So this is 1 by tan x. Here I am multiplying 1x. So here also I am multiplying 1x. So then it balance. Okay. So and separately apply the limit to this. 2x by tan to x when x tends to 0. And for this it is the limit x tends to 0. Separately apply the limit. This into 2 into limit x tends to 0. Secant square 2x by secant square x. You apply the limit 0. Yes, now we have k is equal to, you know that limit of theta by tan theta, theta tends to 0 is equal to 1. So its value is 1 and its value is 1 into 2 into secant square 0 by secant square 0. Secant 0 andre 1. So this is 1 by 1. So k value is equal to because secant 0 is 1. Secant 0 value is 1. So like this we can evaluate this one. K is equal to 2. Similarly, one more example. X cos of 1 by x by 1 by x is there. If you apply the limit to this, let k is equal to limit x tends to 0 x cos of 1 by x by 1 plus x, which is equal to if you take x is equal to, I think in this problem, so x tends to not 0, it is x tends to infinity, you make it as infinity, x tends to infinity. So it is infinity because it not takes infinity by infinity form when it is 0, because in denominator 1 bandbidutte. So take it as infinity by infinity. So when x tends to infinity, then we have, so it is infinity into cos of 1 by infinity is 0 by 1 plus infinity, that is infinity by infinity is indeterminate. If it assumes indeterminate form, so then apply L'Hospital rule. Apply L'Hospital rule. So then k is equal to limit x tends to infinity, differentiate x cos 1 by x. So differentiation of x is 1 into cos 1 by x plus x, you keep it as it is, differentiation of cos is minus sin of 1 by x. Again differentiation of 1 by x is minus 1 by x square. It is minus 1 by x square. In denominator we have 1 plus x. Differentiation of 1 plus x is 1. Differentiation of 1 plus x is 1. To this, if you apply the limit, k is equal to, okay, simplifying this first, limit x tends to infinity, cos of 1 by x, minus of minus plus, 1 of this x cancels, okay, it is sin of 1 by x sine of 1 by x divided by x, sine of 1 by x divided by x. So when x tends to infinity, so then what we get here, which is equal to, so that is k is equal to 1 by x. Okay, right, it is limit x tends to infinity cos of 1 by x plus limit x tends to infinity sine of 1 by x by 1 by x. I am taking 1 by x here. To balance this, we have to multiply 1x here. So that is limit x tends to infinity. This is x. So it is 1 by x. Already one x is there in denominator. So that x into x is x square. Okay. So now it is k is equal to, yes, all of you know that it is cos of 1 by infinity. Its limit is cos of 1 by infinity plus limit, if you take when x tends to 0, so then 1 by x tends to 1 by infinity, 1 by x tends to, so when x tends to 0, then 1 by x tends to, when x tends to infinity, then 1 by x tends to 0. So limit 1 by x tends to 0 into sine of 1 by x by 1 by x into limit x tends to infinity 1 by x square. Okay, it is now, it is visible. Yeah, it is sine of 1 by x. This is sine of 1 by x by 1 by x limit 1 by x square. ಯಾಕೆ ಹೀಗೆ ಬರ್ದಿರೋದು ಅಂದರೆ x tends to infinity ಆದರೆ 1 by x tends to 0 ಆಗುತ್ತೆ. 1 by x tends to 0. So you write it is limit 1 by x tends to 0 sine of 1 by x by 1 by x. So in place of 1 by x you can write theta, sine theta by theta, theta tends to 0, like that. And you apply the limit to this. 1 by infinity is 0, it is cos 0 plus, and according to, so by using formula it is 1, it is the standard limit, and to this one you apply the limit 1 by infinity. So that is cos 0 is 1, 1 by infinity is 0, so its value is 1. So limit of cos of x into cos 1 by x by 1 plus x when x tends to infinity, this is equal to 1. Similarly, you try to solve this problem, limit x tends to pi by 2 log of x minus pi by x by tan x. And one more example is there, limit x tends to pi by 2 secant pi x by tan 3 pi x, secant pi x by tan 3 pi x. So x tends to, so if possible you make it is secant x by secant, so if you take pi, then it is difficult to find that value, secant pi by 2. So what is the cos pi by 2 is, so ಇಲ್ಲಿ pi ಬೇಡ ಇದು, so left this pi ಬೇಡ ಇಲ್ಲಿ. So secant x by tan 3x, secant x by tan 3x, not tan 3 pi x. Okay, it is tan 3x, that's all. So try to evaluate these two limits. It's the problem of the infinity by infinity form. Okay, so in next session I would like to discuss some more indeterminate forms like 0 into infinity, infinity to the power of infinity, so that one. So okay, thank you.